Good morning friends. After the discussion of the illustration 12.1 and 12.2, already these two illustrations are cancelled for the board exam, but not for the competitive exam like as the JEE. Now today we start our discussion about the illustration 12.3. Here the question is that it is found that the 13.6 electron volt energy is required to separate a H atom into proton and an electron. Compare the orbital radius and the velocity of the electron in hydrogen atom. We have to find out the radius of the nth orbit of the hydrogen atom and what is the velocity of electron in nth orbit. Right? For that purpose, here the total energy of the hydrogen atom is given. There is the 13.6 electron volt energy. First we look down what are the data required for the mass of electron 9.1 into 10 raised to minus 31 kg. Charge of an electron 1.6 10 raised to minus 19 joule. Right? After that, the total energy is given in form of 13.6 electron volt. That is the minus 13.6 electron volt. Therefore, minus 13.6 into 1.6 into 8 is to minus 19 joule. We have to calculate the orbital radius and also velocity of an electron. Therefore, total energy of H atom, hydrogen atom, E is equal to minus square upon 8 pi epsilon 0 r. R is the radius. But we know that K is equal to 1 upon 4 pi epsilon 0. There is a Coulomb's constant, its value is 9 into 10 is to 9. Newton meter square per Coulomb square. Substitute here. Therefore, minus K square upon 2R is equal. Right? Now we require the radius. Therefore, R is taken left hand side is equal to minus K square upon 2. We substitute the value K 9 into 10 is to 9. Right? Electron charge of an electron 1.6 10 is to minus 19 whole square upon 2 into total energy, that is the minus 13.6 into 1.6 into 10 is to minus 19. So one time there is cancel 1.6 into 10 is to minus 19 with these two. Okay. Now this minus becomes the plus. As we simplify, we obtain the answer is 0.52974 into 10 is to minus 10 meter. Now we can add, that is the approximate 5.3 into 10 is to minus 11 meter. There is the radius of electron in hydrogen atom. Right? Now we require what is the velocity of an electron. Therefore, the total energy of electron E is equal to minus E, kinetic energy. Therefore, K is equal to minus E. K is equal to minus E. We know that K is equal to half mv square. Half mv square. So we add later here K is equal to this minus half mv square. Therefore, V square is equal to minus 2E upon M. H is substitute the value of total energy in mass of an electron. Right? So we obtain the velocity of an electron, so is equal to minus under root of 2e upon a. Therefore, velocity of an electron in hydrogen atom, V is equal to minus sign under root of 2. Total energy of an electron minus 13.6 into 1.6 into 10 is to minus 19 joules upon mass of an electron, there is the 9.1 into 10 is to minus 31 kg. When we simplified, we obtain 4.78 into 10 is to 20. Taking the square root, therefore 2.18 into 10 is to 6 meter per second. That is the approximate 2.2 into 10 is to 6 meter per second. That is the velocity of an electron. Again, here the total energy of electron is given in hydrogen atom to separate the electron and proton. Therefore, total energy is minus square upon 8 pi epsilon 0. We know that the Coulomb's constant K is equal to 1.4 pi epsilon 0, its value is 9 into 10 is to 9 Newton meter square per Coulomb square. Substitute here, therefore, the equation becomes E is equal to minus K square upon 2R. Therefore, I is equal to minus K square upon 2E. Let us substitute the value of K, Coulomb's constant, 9 into 10 is to 9, E charge of an electron, 1.6 into 10 is to minus 19, and E is minus 13.6 electron volt is equal to minus 13.6 into 1.6 into 10 is to minus 19. So, let us simplify the radius of the electron in hydrogen atom. We obtain 5.3 into 10 is to minus 11. Now we require also the velocity of the electron in hydrogen atom. For that purpose, the total energy of an electron E is equal to minus E. Kinetic energy is equal to half V square. Therefore, the equation of velocity V square is equal to minus 2E upon M. Therefore, V is equal to minus under root of 2E upon M. Now we substitute the value. V is equal to minus under root of 2. Here E minus 13.6 into 1.6 into 10 is to minus 19. This negative becomes the positive. Right? Then, and divided by 9.1 into 10 is to minus 31. Therefore, we obtain the V is equal to under root of 4.78 into 10 is to 20. And final value of V is 2.2 into 10 is to 6 meter per second. Now, next class, according to classical electromagnetic theory, calculate the initial frequency of the light emitted by the electron revolving around a portion in hydrogen atom. Right. For this purpose, here we consider the radius of the electron R is equal to 5.3 into 10 is to 11. Minus 11 meter, and velocity of an electron is just we found 2.2 into 10 is to 6 meter per second in earlier illustration. Right? We have to calculate the initial frequency here. Now we know that the relation between the linear speed and angular speed V is equal to R omega, but omega is equal to 2 pi f. Therefore, R into 2 pi f. Therefore, frequency of rotation of an electron F is equal to V upon 2 pi r. V upon 2 pi r. Now we substitute the value of velocity 2.2 into 10 is to 6 upon 2 pi 3.14, radius 5.3, 10 is to minus 11. As we simplify, we obtain the frequency is 6.6 into 10 is to 15 Hertz. 10 is to 15 Hertz. Again, here the radius and velocity we have to consider from the earlier elasticity 12.3. Already we found the radius of the electron in hydrogen atom is 5.3 into 10 is to minus 11 meter, and velocity is 2.2 into 10 is to 6 meter per second. We know the relation between the linear speed and angular speed. So V is equal to R omega, but omega is equal to 2 pi f, therefore R into 2 pi f. Therefore F is equal to V upon 2 pi R. Substitute the value V 2.2 into 10 is to 6 upon 2 pi 3.14, and radius is 5.3 into 10 is to minus 11. We obtain the frequency is 6.6 into 10 is to 15 Hz. Right? So there is one answer. Now, next illustration, a 10 kg satellite circles Earth once every 2 hours in an orbit, having the radius of 8,000 km. Assuming the Bohr's angular momentum postulate applied to a satellite as it does to an electron in hydrogen atom, find the quantum number of the orbit of the satellite. Here the mass of the satellite is given, there is the 10 kg. Radius of the evolving is given 8,000 kilometers. That means the 8 to 10 is to 6 meters. The periodic time is given T is equal to 2 over. That means 2 into 36 seconds. Therefore 7200 seconds. 3600 seconds. 1 hour is equal to. Therefore 2 hours is equal to 7200 seconds. We have to find out the momentum. The quantum number. Right? Okay. Now from Bohr's angular postulate, the angular momentum of satellite must be in this multiple of h upon 2 pi. The angular momentum of the satellite is mvr is equal to nh upon 2 pi. We require the value of n. Therefore, n first, v is equal to 1. But v is equal to 2 pi r upon t. 2 pi r upon t. Because the satellite revolves in nth orbit around the Earth, radius is r, number of orbit is n. Therefore, in one periodic time, in the distance is equal to, linear distance is equal to circumference of this orbit. Circumference is 2 pi r, and time taken is capital T periodic time. Therefore, linear speed v is equal to circumference upon periodic time. Substitute here. Therefore, m into 2 pi r upon t into r is equal to n h upon 2 pi. V quadrant, therefore n is equal to 4 pi square r square m upon t into x. Here we substitute the value 4 pi 3.14 whole square. Radius r is 8 into 10 is to 6 whole square. Mass is, that is given the 10 kg, divided by periodic time 7200 and Planck's constant 6.6 into 10 is to minus 34 joule into second. Thus we obtain the quantum number is 0.5287 into 10 is to 46. It means the 5.3 into 10 is to 45 fifth orbit. So as we compare the location of the satellite of the Earth around the nucleus, so there is a quantum number for this satellite revolved around the Earth. Yeah? Oh. Okay, now last illustration of this chapter, chapter 12 atoms in 12.6. Using the Hilbert's formula, calculate the wavelength of first 4 spectral length in Lyman series of hydrogen atom. Again, we have to use the formula of Hilbert constant. Calculate the wavelength of first 4 line. That means the H alpha line, H beta, H gamma, and H delta line in Lyman series of hydrogen atom. Now, what is the Hilbert's formula? The Hilbert's formula is Hc upon lambda IF is equal to Ne/4 upon 8 epsilon 0 square h square into bracket 1 upon Nf square minus 1 upon Ni square. Actually, our equation is 1 upon lambda IF, that is the general equation, is equal to R into 1 upon Nf square minus 1 upon Ni square. R is equal to AB is to 4 upon 8 epsilon 0 square CH cube. Right? Here the H and C is taken here. Therefore, Hc upon lambda IF is equal to Ne is to 4 upon 8 epsilon 0 square h square into bracket 1 upon Nf square minus 1 upon Ni square. Right? We require the wavelength of first 4 lines. For Lyman series. For Lyman series, Nf value of Nf is 1. For Lyman says Nf is equal to 1, and this constant Ne is to 4 upon 8 epsilon 0 square h square. As we substitute the value of m, mass of electron 9.1 into 10 is to minus 31 kg, E, charge of an electron 1.6 into 10 is to minus 19 joule, epsilon 0 and h, we get its value is 21.76 into 10 is to minus 19 joule. That is the value. Right? Therefore, considering this value here, therefore Hc upon lambda IF is equal to 21.76 into 10 is to minus 19. Here, 1 upon 1 minus 1 upon Ni square. Therefore, take Hc in this side, or in other words, that is taken here. So it's equal to 21.76 into 10 is to minus 90. Here, Ni square is the LCM. Here, Ni square minus 1. We require the value of lambda IF taken here. Therefore, lambda IF is equal to Hc upon 21.76 into 10 is to minus 90. This term is in this side in denominator, reciprocally multiply Ni square upon Ni square minus 1. Substitute the value of H and C. Therefore, Ni square into H 6.625 into 10 is to minus 34. C, velocity of light in vacuum 3 into 10 is to 8 meter per second. Right? Upon 21.76 into 10 is to minus 90 into Ni square minus 1. Ni square minus 1. So as you simplify, we obtain there is the Ni square into the simplification of this numerical value is 913.4 into 10 is to minus 10 upon Ni square minus 1. That is the equation of wavelength when the electron make the transition from ith orbit to the eighth orbit, like lambda IL is equal to Ni square into 913.4 into 10 raised to minus 10 upon Ni square minus 1. That is our equation 1. As we take the different value of Ni, like as the 2, we obtain the wavelength of alpha light for Lyman cells. As we take the 3, we obtain the wavelength of beta light. As we take the 4, wavelength of gamma light. And as we take the 5, wavelength of delta light, 4th light. Therefore, taking Ni is equal to 2. The wavelength of alpha light of Lyman cells is obtained. Therefore, lambda here I is equal to 2, f is equal to 1. Lambda 2 1. Lambda 2 is equal to 2 square. Here 913.4 into 10 is to minus 10. 10 is to minus 10 upon 2 square minus 1. 2 square minus 1. If we simplify, we obtain the answer is 1217.8 into 10 is to minus 10 meter. That means there is a 1218 angstrom. 1218 angstrom. There is a wavelength of alpha light. There is the first line of hydrogen atom of the Lyman cells. Okay. Now taking Ni is equal to 3. The wavelength of beta light of Lyman cells is obtained. Right. Therefore, taking the Ni is equal to 3 in our equation, lambda 3 1 with the lambda beta 3 square into 913.4 into 10 is to minus 10 upon 3 square minus 1. So as we simplify it, we obtain the answer is 1027.5 into 10 is to minus 10 meter. Right? So that means the 1028 angstrom. There is the wavelength of second line of Lyman cells in hydrogen atom. That means the beta light. Now taking Ni is equal to 4 in our equation. The wavelength of gamma light of Lyman cells is obtained. Therefore, lambda 41 is equal to 4 square into 913.4 into 10 raised to minus 10 upon 4 square minus 1 in our Poynter equation. As we simplify, so we obtain the answer is 974.29 into 10 raised to minus 10 meter. Therefore, lambda 41 wavelength of gamma light is 974.3 angstrom. That is the gamma light. Similarly, taking n is equal to ni is equal to phi. Ni is equal to phi. The wavelength of delta of Lyman cells is obtained. Therefore, lambda phi 1 is equal to phi square into 913.4 into 10 is to minus 8 upon phi square minus 1. So the simplification is 951.45 into 10 is to minus 10 meter. That means the 951.4 angstrom is the wavelength of delta line. So friends, there is very easy only way to keep in mind the equation of the apex formula. Actually, the 1 upon lambda IF is equal to R into bracket 1 upon NF square minus 1 upon NI square. But here we substitute the value of Hilbert constant R in form of ME is to 4 upon 8 epsilon 0 square C H cube. First, we obtain the general equation of the wavelength lambda IF for the Lyman cells is our NI square into 913.4 into 10 is to minus 10 upon NI square minus 1. Now, taking the different value of NI, as we take the NI is equal to 2, we obtain the alpha line for Lyman cells and its wavelength. Now, by taking the NI is equal to 3, we obtain the wavelength of beta line for Lyman cells. As we take the NI is equal to 4, we obtain the wavelength of gamma line of Lyman cells. And as we take the NI is equal to 5, we obtain the fourth line, that is the delta line of Lyman cells. Clearly, very easy. Only the beginning, the equation is required. Clear?